Hey everybody, welcome. Sorry, whoa, what's going on in the chat? Oh, what is it? What are we talking about? Oh, okay, y'all talking about the weather. Yeah, welcome everybody. Happy also superhero day. Welcome. Let me go ahead and transition us into our check-in question. Also, welcome to your last day in the module too. So that's also something major going on today. Okay, here's like a would you rather kind of question. I always like asking these questions to my younger sister. We always ask weird questions. But anyways, would you rather sing in front of the whole school or be in a spelling bee in front of the whole school? So that's our check-in question. Would you rather? Go ahead and answer that in the chat because I definitely need to double check who we have here. Like this period started so fast, so a lot of us just poured in, and I don't want to accidentally mark someone absent. Oh, wow. So majority are saying spelling bee. Okay, there's a few who are like, I'd rather sing. My singing is too good to be free. That's a good one. Spelling bee. I'd rather be in a spelling bee, even though I can't spell. Spelling bee, singing, spelling bee. So I basically would do spelling bee. Number one, my spelling is super bad. I always do typos and I rely on Google to correct me. Um, and my singing is really horrible too. So the one that I would be like kind of booted out the quickest would be the singing, the spelling bee. So I wouldn't want to torture people with bad singing for a long time. So spelling bee it is for me. Awesome. Thank you all so much for sharing. Again, if you didn't answer this, if you could please, so I could see who we're missing. Um, and then y'all can correct me if I'm wrong because I don't want to mark anyone absent. Okay, so this is who I'm missing, y'all. I'm missing Tyree. I'm missing Dennis, Miles, Marvin, Alacia, Marco, and Bianca. Let me know if that's right. And I'm so sorry if I missed you. Um, and I'm marking you absent. Let me know if that's right. All right. So, okay, that's who we're missing, y'all. Tyree, Dennis, Miles, Marvin, Alacia, Marco, and Bianca. So I'm hoping to get them in. Oh, we just got Tyree. So let me go ahead and fix that. All right, y'all. Oh, nope. Ooh, we also got, I actually didn't mark him absent, but we're getting more of us in, so that's great. Cool. Make sure you text your friends and all that. You know what? When I was in the spelling bee, actually in fifth grade, no, fourth grade for me, I spelled the word root wrong. So that's how bad I was at spelling. So when I was younger, um, I think what they wanted was the route, but I spelled root like root of a tree. So that's what happened to me in fourth grade. But yeah, thank you so much for sharing, y'all. Those are great stories there in the chat. All right, so let's go into our agenda, everybody. Last day, as you know, we started in our groups yesterday, getting a start on that mini final together and kind of looking at it, putting our heads together on how to kind of revise our own work and how to create like a unified answer here. So we're going to continue that because we're not done yet, of course. Group feedback, that's usually when I bring the groups back. Sometimes it happens in the middle, sometimes it happens at the end. It depends. Like if I'm seeing a lot of misconceptions, I go ahead and bring everyone back. Then I go release you back into your groups. And then we'll have a little checkout at the end of class. So the mini final version, so the final version is due tonight. The final version of your, we need everything today because tomorrow is your teacher's grading day. Of course, you could let your teachers know, of course, if you need any type of extension, but you want to make sure you hold yourself to it. At least turn in a draft. That's what I want to tell you. Because if you turn in a draft and it's developing, that's That's better than getting nothing at all for the score. So at least turn in a draft would be great. But of course, I'm going to be grading it as like with the rubric emerging, developing, proficient, advanced. So that's what's happening. Let me know if anyone has any questions about that. And we just got Marvin. Let me just edit that before I check the chat. All right. Oh, and we're getting Dennis as well. All right. So let's see. I spelled dinosaur wrong in the 5th grade. I mean, I'm pretty sure I would have spelled that wrong back then too. And then Jorge put, should have asked for the word in a sentence. I should have. Actually, I think I did, and I still spelled root, like root of a tree, instead of a root. I don't know. I say route when it's the other spelling. So, yeah. All right. Let me know if anyone has any questions about mini final, what we're doing in our last day here, anything like that. And then I'll just pause to see. If we don't have questions, I'll go ahead and move us on so we could get back into our groups. I also might need some support. I did take a photo of the groups I had the other day, but I did know some people were coming in and I put you in groups. So if you're in the wrong group, don't worry, we'll try to correct that. So I'm gonna try I have the list with the original one. So let me know. So if you didn't get grouped, you'll probably still be here, and just let me know who were you working with the other day and I'll put you there. All right. So as a reminder, these were the essential questions that we had answered the other day. The reason why I'm going over this is you might be using this when you justify in your mini final. So how can I determine how fast an object is moving at an exact instant in time? That's when you take 2 points and you move them very, very close together, and or you take 1 point and you move it next to your point of interest. Point of interest is the point that you're interested in investigating. And we got miles, yay. And how is the slope of a function connected to speed? So as we saw, and you can even see in this visual here, the steeper the slope, the faster the motion. Because as the slope got steeper, notice how the slope, the number got larger and larger. It went from -3 to -7.9. The speed also got larger if you make these numbers positive. Cool. So that's just a little bit reminder of those kind of big ideas. All right, so now we're gonna just pop back into our groups. The Desmos links should be the same as yesterday. Give me a second to make the groups. Make sure that we're sharing screens. All of you did that the other day, so we're good. And again, if you're in the wrong group, just let me know. Just tell me who you were working with and I'll put you in there. All right, so I'm gonna try this. Let's see. Okay, so give me a sec, y'all. I'm gonna go ahead and try to place everyone in their groups. Let me just mute myself for a sec, but feel free to ask some questions. Someone says, did I have a group? If you were not here yesterday, I'll try to place you in a group anyway, so it's okay. All right, and then feel free to unmute if y'all have any questions or anything. Yeah, this is so interesting. It's a little bit interesting how the groups are showing up here on my side. Okay, I'm doing group 1 right now. And again, you might have 4 or 5 people in your group. That's okay. Okay, I'm in my last group, everyone. So I'm gonna go ahead and just put who's remaining in the last group. All right, here we go, y'all. Sorry, took a while. But again, same Desmos link. Let me open all the rooms. All right, everyone, see you soon. And Dennis, I put you in a group, so just go ahead and accept the invite. All right, y'all, go ahead and accept your invitation to your group. I'll be joining y'all in a second. And wait, Henry, did you get a group? Okay. And then, all right, and then Maria, do you see an invite there? Okay. Hey, Niara. Let's see, where were you at yesterday, the other day? You were with Francisco's group?
Yes.
Go ahead and add you there. Wait, I hope that was the right. Hi group. So I think this is the group that wasn't here yesterday. So we do need like a screen sharer, and then we're just gonna have someone just start on the Desmos. I don't think anyone was here yesterday. Unless you were, let me know. So who can do screen sharing for this group? I'm on phone, so Maria can't do it. All right, who else can?
Me too. I'm on my phone.
All right, how about you, Sitlali? So this is what I might do. So let me know, Saladi, if you could screen share. Okay, I can, but my computer's slow. So I think, let me know if I'm right. If you all weren't here the other day, I think I'm gonna have to just spread you out and have you join other groups. The groups are like in the middle of the Desmos, but I still think you all can learn from at least watching and seeing where everyone's at. That way we don't have to kind of problem solve about the screen sharing. But let's see. So Maria says, I think I can go on my computer if you want. It's up to what you all want, because I think like we could do that. Okay. Yeah, okay, y'all want to do that? Yes, that works then. Let's try that out. So if you go on your computer, I'm gonna have to just make sure I check that you're joining. I'll be checking to make sure I let you in if you're joining from your computer. Okay, I'll be back to check in on this group. Awesome.
To be the steepest, right?
Yeah.
Okay. So I will write using 3.14. But for this one, we have to also solve using the y2 minus y1 equation, right?
Yep. So we can choose like 2 close points. So you can try and get like the exact speed.
Oh, y'all finished the Desmos? That's awesome. I'm seeing there in the chat. Okay, cool. Y'all can definitely discuss and or share your mini final as well. Awesome. I'll be checking in on other groups. Y'all have your little work time there. And or let me know if y'all need me to check on something. Like if you have any questions about any of the answers you got here in the Desmos, I'm happy to do that too. I'll be back though.
What were you saying?
I said, well, like, can't we find the average speed if we just find a point at 11 minutes and then divide the distance by like 10 or 11 and then multiply that by 60?
What?
Never mind.
I mean, can you do it and see what you get and tell us?
This is for question number 1, though. I think
Hmm.
we're on question number 3.
For the mini final
Yeah.
for this one?
Oh man, your names are not anonymized, huh? I'm gonna go in and make sure that happens. Sorry.
Uh-huh. Wait, how'd you get this?
Hey Maria, I hope you don't wait long. Let me go ahead and put you back in the group. Give me a sec. Uh-oh. All right, awesome. It looks like y'all got the screen sharing going. Cool. Hey everybody, I'm just waiting for all of us to come back before I start giving some feedback to some of the answers I'm taking a look at. Fix my hat here. All right, good. I think we have mostly everyone back. Welcome back, y'all. Don't worry, you'll be back into your groups once I give a little bit of feedback. So let me just move this thing here. So I'm quickly checking in to see what y'all said about where the steepest, between which 2 points of these ants, of this ant's motion was the steepest and or the speed is the greatest. All of you said between A and B, and y'all for the most part had good reasoning. And let me go ahead and just check out number 7. So most of you agreed that at point B, the ant's instantaneous speed was the greatest. And then there is a student who, or a group who said point A. Now, so I think this group kind of like did probably like a little calculation around point A, and they got 27.9. But 27.9 kind of reminds me of what we did for number 1, I believe. In order for you to check whether a point is steeper or not than another point, when you're talking about instantaneous speed, is you want to imagine that you're drawing like a line right at the point. It's kind of intersecting the point like so. So that would be like a way for you to estimate the slope at the point. And if I was to draw a line on point B, notice how this line is steeper than A's line. So the correct answer is B. The ant is moving the fastest at that instantaneous point in time. So just as the answer for that one, the answer is B. That the reasoning is for that reason, the slope at that point is more steeper. You could also see at point B, the graph is increasing the fastest at that point. And a lot of you said that in your explanations. So I just wanted to make sure that we all got that. Yay. So we made some adjustment there. Okay, so the point I really need to talk about is slide number 8. So as you can see, we do have a variety of answers. Now this part is super important because this is where we need to check whether or not the teachers were speeding or not. So if the teachers are going above 75 miles per hour, that means they're speeding, and we have different calculations that I see here. So in Nina's group, they say they're going around 78 miles per hour. William's group also says 78 miles per hour. William's group did like mostly like an algebraic kind of explanation with symbols. And then we have Ernest's group who thinks it's 73 miles per hour. It says because that's what the officer explained to them, how fast they went after pulling them over. And Hertha's group says 66.78. And they kind of did a little explanation. And then George's group said between points 2 and 4. So I agree that between points 2 and 4, the graph looks the steepest. But what we want to answer is what's the fastest speed? And remember, y'all, when we're doing speed, that means you're going to be using that slope formula, y2 minus y1. x2 over x1. So we have to actually incorporate that formula. And that's what you see kind of happening here in Williams's group. So because we have 2 answers that are saying 78 miles per hour, I kind of want to investigate what this group did. So they got 78 miles per hour. And if that's the case, that means that the teachers are indeed speeding, right? Because they, at one point in their drive, went above 75 miles per hour. So let's see what Nina's group did. So they said they chose 2 points, 3.15 comma, and they got 1.582, and 3.14 comma, 1.569. It says because they were the steepest part of the graph and they were closest to each other. So let me just also kind of pull up what this group is trying to do. But I would want to strengthen it because I want to say like, well, what big idea are you using when you're saying close? The points are closest to each other. And I'm imagining they're applying our instantaneous rate of change big idea, where when the 2 points are very, very close together, you're going to get an instant rate of change, or a rate of change that's happening at an exact point in time. Kind of like you're calculating what's on their speedometer. So that's what I'm seeing when they're saying make the points as close as possible or really, really close is what I see here. Is the steepest part of the graph and they're close to each other. Again, in your own mini final, you want to connect that to a big idea. And the big idea that I see here is instantaneous rate of change because they're choosing points that are really close to each other. That's telling me instantaneous rate of change. And then what they did is they calculated the slope and that's how they got this. And this group did the same thing. So this is kind of like algebraic representation of what Nina's group did. And Nina's group was kind of like added more justification and explanation to it though. If you combine these two answers, that's a really, really great response in the mini final. But anyways, let's go ahead and talk about why Nina's group chose those 2 points. And I also want to point out why this last group, George's group, said between 2 and 4. Because everyone's like in the right track there. So if you look here, and I'm using the tool that I gave you all on the Desmos, the tool that's on this slide right here. And what I did here is I put the function, the same one that we're investigating, and you could zoom out and you could see how it looks like. And your goal is if we want to figure out the fastest speed that the teachers went, we're going to be looking for points where the slope is the steepest, right? That's making connections. Steeper slope means faster speed. So that's what I'm looking for. So as I move this line, it's kind of like a way to help us kind of visualize where the slope is the steepest. So as you can see, it gets less steep once I pass 2 and 4. So then I'm going to go back to the points between 2 and 4 and kind of investigate around which points there is going to give me the steepest slope. Steepest slope means this line here is going to just get steeper and steeper, and I see it getting steeper as I'm moving down. And it kind of pauses around here in this area. So I'm at like 3.2. And let me go back to see what they got. They said at around 3.15. Let me just imagine I'm trying to get to that point too. I'm gonna just put 1.5. So that's according to that group's investigation. And then what they did is they chose a point that's very close to this point. So they chose 3.14, I believe. And you're gonna have to just play around with it. But once they found the 3.14, they found the slope of that. And according to their calculations, they got 78 miles per hour. And you can see Williams as well. Now this group got 73 miles per hour, but I kind of need some more evidence so that I could kind of see what the group did. It doesn't matter what the officer said, right? We're looking at the actual evidence, the actual graph, and trying to apply average rates of change and instantaneous rate of change. Now this group, I'm very interested because they have good explanation, but they got a speed that's not speeding though. Oh, okay, so this is what they did. They looked at the number between 3 and 4, it grew quickly. So I plugged those in and they got 1.13 times 60 and they got this. So I'm assuming they looked between 3 and 4. So 3 would be down here and 4 would be up here. So what this group did is they're finding an average rate of change, first off. But these 2 points between 3 and 4 are actually too far to be called an instant rate of change. So what that group found was an average rate of change, and the points between 3 and 4 are too far from you to determine exactly at an instant if they were speeding. So that's the feedback I would give to that group. 3 and 4 is a little bit too far. We want to try to apply the big idea of instantaneous rate of change. You got to choose 2 points that are very close to where the steepest point in the graph appears to be at. So that's just some feedback. I know, I'm sorry if it's taking too long. The last thing I want to give before you all hit back and work on this is Miss C. A lot of you, like for example, Nina's group said, according to Miss C, she said that they were going 0.5 times 60 is 30. So they were going 30 miles per hour with her method. Actually, if we go back, Miss C is the one who said that she was calculating the average rate of change for every minute. So she was kind of doing what that one group was doing, like between 3 and 4. That's too far apart for you to get an actual instant rate of change. So that's what Miss C was doing. So that's what you want to go back to when you read it. I think that group confused it with what Miss S said. She said something about 0.5 mile per minute. So you want to go back to what Miss C said when it comes to slide number 9. Does anyone have any questions? I know I did a lot of talking. Anyone have any questions about the feedbacks or anything like that before I put you back in your groups, make some edits, anything like that? All right, y'all. I'm gonna go ahead and put you back in your groups. Good luck. I'll be just popping in, but I'm definitely looking for some, adjustments and answers and things like that. See you soon. Groups are open. I'll be popping in. Oh, wow, that's, yeah.
She wasn't calculating the instantaneous rate of change. I think she was just calculating it by the minute. So it wasn't like during that moment, if that makes sense.
Yeah, she calculated like longer time
Mm-hmm.
because
Okay. I was running shotgun and I checked the odometer reading every minute. So I used that to calculate our speed, but I can tell you that we never moved faster than 75 miles per hour.
Well, if she was looking at it every minute, I'm pretty sure she would have known.
Do we use PEMDAS?
For what?
For finding the speed with their equation?
You're just supposed to use the equation to make a graph on Desmos. That's all you need the equation for.
Oh, wait. So wait, so do we just calculate from 3 to 4 if she only did a minute per minute? Or, I don't know.
I guess. I think so. I think that would be better.
Do we have to do any, I mean, oh. 3, oh god, 1.388, 1.388, or I'll just put it here, 3, 1.388.
Do y'all hear that?
Yeah.
I'm sorry. I don't
Oh.
I don't know how to mute these notifications.
$2.50.
How do I turn on Do Not Disturb on a computer?
Don't know how to do that either.
Settings somewhere. Notifications.
Certain points like the speed is like faster than others, and like, oh, I missed that. Yeah, no, I'm just trying to remember what you were saying, what you were talking about, like the something about the graph, and like, but my Wi-Fi kind of cut out, so I'm just trying to like make what I got from that. Like how at some points like the rate of change was like faster, and other points it was like how Miss Ella said she was trying to find like a, I don't know. I just remember her explaining something about like the reason why they got like this like slope or something was because like the 2 points they chose was like very broad or something.
Mhm.
That's how I got.
Yeah,
It could
yeah.
be.
And when your 2 points are broad, like when they're too far apart, you're not going to get a good instantaneous speed. And the points need to be close together if you want at that instant, how fast are we going? So you actually have to zone in on the spot where the slope looks the steepest on the graph and try to choose 2 points that are really close. But Miss C couldn't do that because she was recording every minute. And so she's doing average rates. She's not doing instantaneous rates. That's the key here.
She's doing average rates.
Oh, so
Yeah.
like
Average versus instantaneous rate.
Was the other one instantaneous or
Yes, instantaneous. And that's the one where I was kind of showing the palette, when your points are
Yeah.
really, really close together, that's instantaneous.
so
But when
then
they're
average is a different it's a different method, right?
average, well, they both, you're going to have to use the slope formula. The only difference between the two is that average rate of change, the points could be close or far, but for instantaneous rate of change, they have to be really, really close. And that's going to give you the instant rate. That's the
So
only
for
difference.
this question, are we looking for the average or the instantaneous?
Well, what did Miss C do? She was measuring every minute only. So what would you say she was doing?
oh, that's the average.
That's going to be an average because a minute for when you're driving, like a whole minute, you could do a lot of crazy speeds in that minute, and your average is not going to really tell you much. What you want to investigate is the instantaneous. So
So
Miss
then,
C, yeah, was doing the average.
okay, so then we're gonna have to go to the graph, right? And we're gonna look for the slope, like the two little points.
Mm-hmm.
So
Yeah, so maybe like if it was Miss C, she would do like 2 points that are like a minute away from each other. And you guys have this table. I could see 1 minute, 2 minute, so between 1 and 2. Or y'all can do between 3 and 4 because between 3 and 4 it looks very steep. And that's the fastest that Miss C would be able to record.
you said 2 and 4.
Well, I'm just reading what's on this table here because I see 1 and 2. I also
Yeah.
see 3 and 4. And if I look
Oh,
at the points
3 and 4.
between 3 and 4, that looks steeper than the points between 1 and 2. So I feel like the fastest speed that Miss C could find is if she tries to figure out the speed between 3 and 4.
Okay.
So try that out. Yeah. Try it out, see what Miss C would get as the fastest speed if she tries that
And
method.
we're still using the same formula, right?
That's right. This whole unit, we've been using the slope formula. So y2 minus y1 all over x2 minus x1. And again, the key here is Miss C is doing an average rate of change. She's not doing instantaneous. And that's why she couldn't find, she wasn't able to see that they were actually speeding at some point in time.
So then, but then at the end, we still have to multiply by 60, right?
Yeah, for all of these, because this graph is miles per minute. That's why.
Okay, thank you.
Welcome, welcome.
Just one other thing. How would you get this type of like equation?
Sorry, go ahead. How would
How would you get this type of equation? Because I'm looking back at it. It says like 0.5 t minus 0.4 sine of t or something.
yeah.
How would you get something like this? to begin
Oh,
with?
how would you get something like that? Like for a car driving?
Yeah, I don't know how you could like generate that type of equation. If you get sine.
Actually, so we create these mini finals. Another teacher, he actually has like a PhD in applied mathematics, and he's actually the one who made this. So to be honest, I'm not exactly sure where he came up with this, but it's supposed to model like a car's travel, a real world car travel motion. So yeah, that's my answer for that. Yeah.
Yeah. See, I don't know. This seems like some complicated math.
I mean, it's okay. I mean, as long as you have the graph and you have your points, you're set. You don't really have to pay much attention to like the sine function or anything like that for this case.
I mean,
Next,
like if this is what's in pre-cal, what's in AP cal?
there's gonna be limits. there's a bunch more things to know. I'll say that. That's the difference. There's a bunch more things. You're going to be calculating volumes. You know how we did areas using Riemann sum? There's like volumes in AP Calc and things like that. So it's just like a continuation and applying your pre-calculus into AP Calc.
Oh yeah, I feel a lot better now. Thanks.
Yeah, for sure. All right, I'll be popping into other groups. Good luck, y'all.
Thank you.
No, it went like this. So there was this big hedge fund, and they were betting against GameStop, right?
Yeah, wait a
then
second.
there
Hello,
was-
Miss Sedano. We just finished and we are here hanging out.
All right, let me know if there's any like last minute questions, clarifications, or anything for your mini final.
Yeah.
No, that's okay.
Sorry for the interruption, Joshua. You were saying?
No, that's fine. So no, I just was saying that.
And 4, 2.501. 0.501.
Like that?
Yeah.
Since she said she only kept track of the
With every minute, yeah.
every minute. We used the, which equation was it again? Was it the, or you can say
I guess it's the slope formula.
the slope.
Minus y1 over x2
Yeah,
minus.
but don't we have to use her equation?
Was this one right to
Minus y1 over x2 minus x1.
well, we got the same thing now. We see how this person.
Mhm.
Are the math teachers guilty of speeding?
Hell yeah.
Were their methods of measuring speed reliable or appropriate for the situation where or not?
I don't think so.
No.
Oh my gosh, did we lose Maria here? Sorry.
Your Wi-Fi went out.
Oh no, oops. I just got to check in this group, my bad. I'm gonna go ahead and bring everyone back though, y'all, so. All right, I'll see you soon in the main room. Hi everybody, just waiting for everyone to come on back so we could do our checkout. And let me just see if I need to add anything. All right, still waiting for everyone to come on back. This is just some general feedback I was thinking about. All right, I'm hoping we got everyone back. Welcome everyone. So I was just typing some feedback based on what I saw, just the general things I said. So first off, through the first day, we all knew we had to multiply our last answer by 60 because we're miles per minute. Other thing you need to know is that whenever you're asked about speed, You know that you need 2 points to find the average rate of change. Oh, and you also need 2 points if you need to figure out or estimate the instantaneous rate of change. And again, those are in our big ideas packet. You definitely want to include language and or references from the big ideas packet to strengthen your justification in your own mini final. The next thing, know the difference between, and this is a shorthand way of saying this, but know the difference between average rate of change and instantaneous rate of change. So that was super important. So average rate of change is you're just finding the slope between 2 points. Cool. Instantaneous rate of change is similar, right? You are still calculating a slope, but the difference is the points are really, really close to each other. When you're investigating an instant rate, super, super close together. So that's the difference. So make sure you know the difference between the two, and make sure to include screenshots as evidence / connections to your model. By model, I mean your graph. Remember, that's going to strengthen your justification when you have that evidence, and you can use screenshots from your group work as well. All right, y'all, let me go ahead and take us into our checkout. The last thing before we head on out. So what next? And then you all have your next class as well, because today's Thursday, so period 2 is next. But what next steps will you do as you work on your own mini final before you submit today? So what are your next steps? You could send this to me privately or openly, up to you. Just in general, what are the next steps that we're going to be doing for ourselves when it comes to working on the mini final? All right, we got finish the questions. Give strong justifications. I love that there's focus on the justifications. Yes, add some graphs, add some evidence, add in the stronger justifications, try to add more pictures. Given that I have a lot of work, I'll probably just turn it in as it is. I really like how real that is, because I mentioned to my advisory, you want to prioritize your work. Right? It is the last day of the module, and I understand there's a lot of deadlines and things like that. So I like that real thing. And I want you all to know that no matter what you turn in, everyone's going to have the opportunity to revise it. You could still continue to revise your work, even if we started the next module next week. So that's good. Right answers make connections between the big ideas and answers. Answer the last question. Yay, we're in the last question. Work on it. Add strong justification. Use evidence and math to giving justification and finishing the final. And then get to start working on it. Yeah, just get started on it. That's already going to be a major thing. And again, y'all, please turn in something, even if it's a draft. Again, that's better than not turning in anything. All right, everyone, y'all have a great day. Happy superhero day. Happy last day in the module. I'll see you. Yeah, bye. See you. Yeah, enjoy. Don't miss this very strong group. Bye, everybody. Enjoy.